and then we'll take a look at a couple more down the line to kind of talk about how we're justifying our answer in 3-3. So we got our diagram in number 1 here. You'll notice on your diagram you don't have any arrows showing that they're parallel. That's our job. We're going to prove that they are parallel by using any other symbols. The only thing I know right here is that this angle and this angle are congruent. Since they have both the same amount of tick marks or same amount of arcs, those are going to be congruent to each other. The first thing I'm going to look for is look at which common line includes both angles, because that's going to be my transversal. And I'm going to highlight that in red, and if you have a color, you can use that. I'm going to highlight this right here. That's going to be my transversal. So right along, which includes both angles, there's your transversal. Now, if two lines are hitting that transversal at the exact same angle, that means that those two lines are going to be parallel. So since CG is hitting right at that angle, since BE is hitting right at that angle, those two are going to be the two that are parallel. So I'm going to say BE, line BE is going to be parallel to, use our parallel symbol, to CG. Since the transversals, including both of those angles, are on the transversal, and then the two lines are hitting that transversal at the same angle, those two lines are going to be parallel. But as always in geometry, what do we have to do? Explain our answer. We got to explain why are those two parallel. Well, it's all about which type of angles we're talking about. So which angles are these? Here it's that pot of 4 angles right here. And then on this other line CG, I've got another 4 angles. This angle that I'm showing congruent, this is in the upper right. This angle is in the upper right. So they're both in that upper right position. They're both in the same position. We're dealing with corresponding angles. The corresponding angles theorem says if you have two lines that are parallel, then the angles are going to be congruent. But now we're going to say if we have two angles that are congruent, then the two lines are parallel. We are now using the converse of the corresponding angles theorem. And you can just write it like that, converse of the corresponding angles. Corresponding angles would be incorrect in this case, because corresponding angles theorem says that if you have two parallel lines, then the angles are congruent. The converse says if you have two congruent angles, then your two lines become parallel. So we're flipping it around. So each of those 2 and 3 are also going to use the converse. Once you figure out the angle type that you're dealing with, that's going to be using the converse. So we're using the flip side of each of those 5 theorems that we looked at in 3.2. Is it okay if I erase this one? We'll head down and look at a little algebra, so you'll probably notice that it's going to be very similar to yesterday's algebra. Once we start looking at these angle relationships, we can start making algebra equations, setting them up. I'm going to look at number 5. Because number 4 is using corresponding angles again. We just kind of talked about that one. So number 5, we're going to find a value for x that makes L parallel to M, and then show your work. So we want to find a value for x that makes these two angles congruent to each other. So we want to make those two equal. Because if we make them equal, then this transversal cuts through at the same angle at these two positions, and it's going to make these two lines parallel. So I got to identify what type of angles am I dealing with. So these are the two lines that are possibly parallel. These two angles are inside, and then I got to look, are they on the same side of the transversal, or are they on opposite sides? They're on opposite sides, so we're dealing with alternate interior angles. And alternate interior angles, we want to make those congruent. So 95 equals 2x minus 5. We'll add 5 over, we'll get 100 equals 2x, which x is then going to equal 50. So if x is 50, that's going to make both of them congruent by the converse of the alternate interior angles theorem. If these two angles are congruent, then that makes these two lines parallel. We're just doing the reverse of what we did back in section 2. So section 3, just make sure whenever you're justifying your answer, you're always proving lines parallel. You're just going to use the converse of each of those angle relationships. I'm going to leave it right there. I'll leave this problem up here, and then I'll come around and help with any others. If you need help getting set up with any other problems, I can help you with that, but I'm not going to take up any more of your time. The rest of the time then is yours. If you have questions from 3-2 that we can go over, happy to help. And I've got answer keys ready to go. I've just got to get them put online. So be ready for that later today. So they'll be on plenty of time. Our quiz is not until next Wednesday. So we got a week yet before our quiz. We'll keep practicing. So we got a little bit of time left. But I'll come around here in just a second and help out with any questions.